Hello, are you people able to hear me?
Yeah,
Am I clear or are you getting any disturbance?
yeah, was
So, yeah, I've asked you people to read some topics, right? Like keywords, identifiers, data types, and model structure. And from digital electronic side, half adder, full adder, multiplexer, demultiplexer. Has anybody gone through these topics? Okay, so looks like nobody has gone through these topics. Okay. Um, okay, we'll come to this at the end. So I will just start today's topics. Okay, just give me 1 second. Okay, so are you guys able to see my screen?
Yes,
Okay, so today is the first session which we are going to talk about uh, Verilog. Okay, so
excuse me, screen is not visible.
it's black screen only.
Yeah, okay.
Now you are able to see it, right? You are able to see, right?
Yes, 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 yes.
Okay. So yeah, Verilog basics. So this is the first session. Um, so in Verilog, when you are coding using a Verilog language, okay, what and all you can use. Okay. So while coding, that is written by lexical convention. Okay. So so what and all we can have. Okay. First thing, while coding this. While coding in Verilog, we can have comments. Okay. Second, we can have keywords. We can have numbers. We can have strings. Okay. Then we can have white spaces. Okay. So basically, these are the things which which will be there in Verilog coding. Okay. So what and all these I will explain one by one. So and the first rule, okay, while the first rule while coding Verilog you need is that whenever you write a piece of code, one line, okay, that code should always be terminated by semicolon. Okay, semicolon should be must at the end. Okay, if you miss semicolon in any line, you will get an error while simulating it or compiling it, whatever it is. Okay. Second thing. Okay. Verilog is case sensitive. Okay, case sensitive in the sense whenever you are using something like ABC or ABC for declaring any variables or something. Okay, this will be different and this will be different, and also ABC or A B C capital C. So this one, everything is different. Okay, so yeah, two things. First one, it should always every line of code in Verilog has to be terminated by a semicolon, and also whenever you are using the names for variables and everything, it will always be case sensitive. That means all of these are different. Okay, they will point to different things. Okay, so yeah, so when we take this first one, okay, comments. Okay, so few of the people in this meeting has, okay, coding experience. Okay, some of the people might not have. So does anybody, can anybody tell me what is the use of comments in coding? Okay, it's a interactive session kind of thing. Okay, so you can just talk. Even if it is wrong, I will not say anything. You can just talk. Does anybody know what is the use of comments? Okay, you can talk.
Uh, Actually, for my understanding, like comments is used to
The voice is not
understand.
clear.
For my understanding, like comments are used to uh, explain each line. Like we when we're writing a coding for like multiple things, like we mention like in comments, like what you're writing for first and what you're writing for second and what you're writing for third. So the comments will help us to understand the code.
Okay, it's kind of partially correct. Yeah. Anybody else? Okay. So yeah. Now, whenever you are learning, okay, in college or anywhere, it will not be a larger piece of code. In the sense, whatever the code you are trying to do, whatever the coding you are trying to do, hardly it will be anywhere around some 500 lines of code. Okay, I don't see anybody coding more than 500 lines. Okay, so comments might not be much useful over there, but when you are coming into the real world, okay, real projects, it will be thousands and thousands of lines of code. Even a single file will be thousands of lines of code. Okay, so if you're right, if somebody is coding, okay, some thousand lines of code, okay, it should be uh, the code should be properly organized. Okay, if the code is only properly organized, then not only the person who is coding but other people also will be able to understand it. Okay, what is the intent of the coding and what and all they are coding. Suppose like here one block is there, okay, here one more block is there. This is maybe we can say it is file 1, okay, file 2, okay. So some code is here, okay. This code is calling some function over here or something over here, okay. And again there, okay, there will be a callback and everything. Yeah, let's say these two files have code, okay. So coding, I mean comments, here you have to write the comment like I am I am trying to generate 1 megahertz clock. Okay. So if you write something over here like trying to generate 1 megahertz clock. Okay. Next subroutine for 1 megahertz clock generation. Okay, something like this. So whenever somebody else is going through your code, or you are only going through your code, here you can come when you see this sorry, just give me a second. Okay, so when you are uh, going through your code, or somebody else is going through your code, he will come and he will see the comment, and he will see, okay, generate 1 megahertz. So this file, this piece of code is trying to generate 1 megahertz code. Okay, and if some function call is here if you have one more comment like subroutine for 1 megahertz clock generation and everything, that means you will understand, okay, this file, this code is for this purpose, this code is for this purpose. Okay, so as like Praveen told, like for he told like for each line what it is doing and everything, we will write comments and all. In larger projects and all, we will not write comment for each lines and everything. Okay, we will have blocks, and for each block there will be few comments. On top of the block, what the block will do, we will write. Okay, so the comments are important to understand the code. Okay, not only for you, for the other people who are working in the project or who wants to understand the code. So these comments are important. So how do you keep a comment in Verilog code? Okay, so if you have a Verilog code, I mean if you have a Verilog terminal or something, so this two slashes, okay, backward slashes, and you write anything here. uh, this is module 1. Okay, so whenever, okay, uh, module tb, okay, and module, okay. So here normally here you will write all your code. Here what you can do is something like uh, module 1 code. Okay, so when you use two backward slashes, that means it is a single line comment. Okay, that means you are whenever you are trying to compile and simulate, this code will, whatever you write after double slashes, it will not be executed. But if you want to, otherwise if you have written something like x is equal to a plus b, okay, now you don't want to run this line, you want to comment this line, you can just put two double slashes though, so that this will not be executed. Okay, so double slash, single line. Okay, but if you want a multi-line comment, what you can do is slash star line 1, line 2, line 3, line 4. If code is like this, then at the end you put again star and again one more slash. This is a multi-line comment. Okay, so when you put multi-line comment, all these 1 2 3 4 5, all these lines will not be executed as a part of the code. Okay, so first, why we need comments? To understand what is the code going to be like doing. Okay, so first is for information. Okay, to understand like what this code is going to do. Second one is to make a code not execute. Okay, so these are two things which uh, which are the uses of these comments. Okay, so I will not go much deeper. This is good enough. So comments, whenever you are writing coding, I mean like whenever you are coding, please try to use comments whenever possible. Okay, not everywhere, whenever possible try to use comments. It is a good practice in, okay, whatever coding it is, not only Verilog and all, everything is like you can just do it. After that, okay, uh, next, okay, I'll be going to white spaces. Okay, so if we have one more code, module tb, okay, and module, here x is equal to a plus b, something like this. There is a space here, there is a space here, there is a space here, okay, something like this. If these white spaces are there, okay, while executing the code, these white spaces will not be considered, they will be omitted from the execution, okay. But a spacing between the variables, I mean like proper spacing between the variables. See, this is operand 1, this is I mean, so this operand 1, operand 2, and so between x and equal and a plus b, okay, if you write like this will be good coding practice, because it like when you look at it, you will be easily able to understand this type of code, okay. So yeah, white spaces will be ignored, I mean they will not be taken into consideration in the Verilog code, okay. But whenever you have strings, okay, white space will be considered. Suppose like if you are trying to print something, okay, so display, okay, unwish session 1, something like this, okay, this will be considered. It will print everything from starting to the end, it will not leave space, okay. The space also will be considered here, okay. Yeah, so next we will have operators, okay. There are three kinds of operators. First is unary, second is binary, third is ternary, okay. So what is unary operator? Okay, what is unary operator means whenever you are coding, okay, see these operators are these I mean like negation or plus or minus or multiplication or division, okay, these all are called operators, okay. I hope everybody knows this, okay. These are all called operators, okay. So in these operators, what and all unary, what and all binary, what and all ternary, we can see. So when you have something like this, x is equal to a plus b, okay. So this is operator, okay. This operator is being performed on this one and this one. So this is called operand, this is also called operand, okay. So here unary means, let's say example x is equal to 5, okay. So if you have only one operand, okay, or if your operation is performing on only one variable, that is called unary, okay. For example, this negation, okay, so x is equal to, if just say y is equal to 1, okay, when do negation of y, that means it will x will be is equal to 0. Here we have only one variable and the operator is working on only one operand, that means it is unary. Okay, so binary. In binary, the operator will will be used on two operands like a plus b or a minus b or a star b or a or b. Okay, so these are the examples of binary. So everywhere you take, okay, there are two operands and the operation will be performed on two operands. So this is called a binary operator. So this is binary operator, binary operator, binary operator, binary operator. Okay, then there is something one more called ternary operator. Ternary operator is also kind of same, but the only thing is it will perform. I mean, it will perform on three operands. I mean, the final execution. Okay, this is the execution dependent on only one variable. This is dependent on two variables, but in ternary it will be dependent on three variables. So, for example, x is equal to, okay, a less than b. Okay, 1 0. So it will be something like this. Okay, so what happens here is this is an expression. This will be evaluated if, for example, a is equal to 1 and b is equal to 0. Oh, sorry, let's say a is equal to 0 and b is equal to 1. Okay, or sorry, let's say a is equal to 0 and b is equal to 1. In this condition, whenever this expression is evaluated, a is obviously less than b, so that means it is true. Okay, or something like, okay, sorry, my bad. Here one more operator we need to take. Here whenever a is less than b, whatever the value of y will be assigned to x. Okay, if a is equal to 1 and b is equal to 0, in which case this is a false condition. Okay, what will happen is this 0 will be assigned to x. So it is kind of working on, okay, this one and this one. Okay, it's kind of, this is one more, one operand is this one more and this is one more. Okay, so the expression depends on three things here. So it is a ternary operator. So you'll not be using it much, but this is for just for the information. Okay, so after this, the next one. So is everybody clear till now? Just raise your hand if everybody is clear. If you don't raise hand, I will understand that you are not clear and I'll ask you question like why, like what's problem with you or why you are not able to understand. Okay, 11 people. Okay. So I am thinking that everybody is clear. These are just the basics. Okay, so we'll be going forward. Yeah. So next one is number format. Okay. So until now, what and all you have learned? What and all you have learned? So whenever you are doing coding, you can do comments, and you know how to do a single line comment and how to do a multi-line comment. Okay. What happened if you use some white space? Okay, and where and all you can use it. Okay, what kind of operators will be there? Okay, so examples. So these things, these small things, okay, I can directly go deep dive into the Verilog, but why I am telling these small things is these questions, I mean, questions will be asked in the interviews based on these topics. I mean, whenever you are a fresher, they will ask very small questions like what is ternary operator? Give me an example. Okay, and how many types of comments are there? Okay, how to come? What is the use of comment? Or maybe what is the unary operator? Or how many types of operators will be there? Okay, so these kind of all questions they will be asking. So keeping that in mind, I am teaching everything like in detail. Okay, yeah. So next one. Okay, now we have when you are using this coding, I mean like when you're trying to code, we have uh, we have to use numbers, okay, to represent something. Let's say if you have a counter, okay, how much is it counted at certain cycle, it has counted till 16 or 15 or 14 or 13, whatever it is. Okay, so when you want to represent number that number can be represented in four types. Okay, I've already told earlier in the uh, first session about the number format, but still I'm not going deep, but yeah, just I'm telling you they are binary, next octal, decimal, hexadecimal. Okay, this contains only two values. This contains eight. I mean two digits. This contains eight digits. This contains 10 digits. This contains 16 digits, including characters like A, B, C, D, E, F. Okay. So how to represent? Okay, these things when you are coding. Okay. So when you want to represent a number, there are two types of representation: sized representation. Okay, this is first one. Second one is unsized representation. Okay, so what are these things? Okay, we'll go to sized one first. So there will be a format, size. Okay, there will be a tick. Okay, after that base format. After that number. Okay, so example I can give you something like 4 take D, then 5. Okay, so what is meant by this 4 tick D5? I will just write. Okay, what does this means? Okay, here how the machine will understand is this is size is equal to 4. That means 4 bits. Okay, then base format is D. That means it is decimal. Okay, and this 5 is the number. That means 5 is the value. Okay, so this is what machine will understand. Okay, I have one question. Okay, uh, so if you have just one bit, how many values you can have? Anybody can answer. If you have only one bit, okay, how many different values you can have?
Two,
To what are those?
1 and 0.
Yes, exactly. So 1 and 0, those are the two different values a bit can have. Okay, so here size will always be in decimal. You have to write always in decimal. That means 4 tick D5 means you have a space of 4 bits. Okay, 0th bit, first bit, second bit, third bit. So when you have 4 bits, how many combinations you can have?
Four combinations.
What? How many combinations?
Like 0 0 4 zeros to 4 1.
Yeah. How many total?
0 to 15.
It is 16 combinations.
0 to 15.
Yeah. So it is 0 0 0. I mean 0 0 0 0 to 1 1 1 1. So 16 combinations. That means we can, when you represent some value with 4 tick, that means this will have 4 bits of space, which means it can hold value from 0 to, it will be 15. Total 16, but 1111 is 15. Okay. So it can have values from something like 0 to 15. Now 5 is the value which we are trying to, I mean, give here. So 5 falls between 0 to 15. So it is a valid value. Okay. So now if you want to, let's say if you write like this, x is equal to 4 tick d 62. Okay. What will happen here? You have only, you can have only 4 bits, but 4 bits will not, cannot be represented by decimal 62. Okay. How many bits are needed to represent decimal 62? Can anybody answer? Hello. So
Yeah.
how many bits we need to represent a
7 bits.
decimal 62 value?
6 bits.
Okay, so the answer is 6 bits. If you have 1 bit, 2. I mean 2 bits, 4. 3 bits, 8. 4 bits, 16. 5 bits, 32. 6 bits, 64. So if you have, okay, 6 bits, then the values you can use, I mean like you can have any value from 0 to 63. So when you try to do this, x is equal to 4 tick d 62. Okay, this x will not, after the execution of this kind of line, okay, there are two possible outcomes. Okay, first one, either you get error that the value which you are trying to uh, have here is exceeding the number of these bits. That is the first scenario. Second scenario, okay, what it will do is 62. Okay, if instead of 62, okay, maybe, yeah, yeah, okay, I don't have here. So yeah, this 62, okay, sorry, where are we? Okay, here this 62, okay, it will be how much? 1 2 4 8 16 32. 32 plus 16, 48. 48 plus 8, 56. 60.
Last
62.
bit is
So
0.
this is the value. So this is the value. Okay. But as we are having only 4 tick D, what it will do is it will take last 4 bits. Okay. It will take last 4 bits and assign x is equal to 1110. So what is 1110? That is 842. That is 8 plus 4 plus 2, which is 14. So x, if you print, it will be 14 only. It will not print 62. Okay, so whenever you are doing the coding, you should be careful, okay, how to use the numbers. Okay, see, you feel like you have written the code properly, okay, I mean correctly, you feel like you have written code correctly, but something will go bad, and if this fundamental basic things goes bad, then it will be very problematic for you to debug it as everything feels correct. Okay, so yeah, so that's why I'm telling you the number format. So 4 tick d 5 means this is size, this is representation of number system, this is the value. Okay, so now for each and everything I will give one example. Okay, so decimal, let's take how much, uh, okay, let's take something decimal. Okay, you can have 4 bit take, 4 bit take d10. Okay, and in binary the same thing can be written something like 4 take b. Okay, here d means decimal, b means binary. Okay, after that 1010. So this you should consider as 10 in decimal, and this you should consider as 1010 in binary. You should not think it as 1010. Okay, then maybe octal 4 take 4, it will be somewhere around 0 1 2 3 8 9 means 1 0, 10 means 1 1, it will be 1 1. Okay, so and hexadecimal 4 tick h, it will be a. Okay, so these all are same, the only difference is number system. Okay, when you are working or when you are trying to code, okay, sometimes it involves binary numbers, sometimes it involves the decimal number, sometimes it involves hexadecimal numbers. Mostly this we will not use. Okay, so when you are going through all these things, just keep it in mind what kind of number system you are using, how many bits are there, how much it is representing, whether the value is falls under the number of space or number of combinations, that you have to keep it in your mind. Okay, now you can have something like in hexadecimal 32 abcd. Okay, okay, if you, array, what happened? Okay, you can have 32 abcd. Okay, just if you put x is equal to 32 abcd, that means x will be something like, okay, sorry, this is wrong. Okay, x is equal to 32h abcd. Okay, what will be actually stored in the x is, it will be something like this, that is 320000 a b c d. Okay, this is how it will be stored. Okay, but if you print, it will just print abcd, but you should keep in your mind that this is a 32-bit space. Okay, yeah, so here when you are working in hexadecimal, you can use something like this, underscore abcd. This one and this one are absolutely same, there is no change. If you put underscore, that does not change anything. Okay, it is just for a good representation we can use underscore, but system will consider it as 0000 abcd only, and this is also how you can use it. Okay, so This is sized numbers. That means size is always here. Size is always mentioned or here. So next, what we'll do is we'll go to unsized numbers. Okay. In unsized numbers, okay, if you write something like x is equal to 20, okay, you don't have anything. You don't have size, you don't have base format, you don't have anything. So in this case, by default, it is considered as decimal. Okay, this is one more question. Okay, interview question they will ask and they'll simply confuse you. What is the default numbering system when you use something like this? Why it is like this? Why it is not like this? So many questions they will ask. You should not be confused. You should be just remembering this thing and you should be confident enough. Okay, by default it is decimal, so x is equal to decimal 20. That means normal value 20. Okay, so this is a by default one. Okay, and also here what will happen is, okay, uh, when you're trying to assign 20 to the x, what will happen is this x will be some kind of variable. We did not discuss the variables and everything, but just for now it is a variable. If it is an integer variable, okay, this will be by default 32 bit. Okay, so if you have, okay, sorry, x is equal to 20. So by default, if it is an integer, earlier if you have given something like integer x, if you have defined something like this, that means by default it is 32 bit, and this 32 bit is a, okay, later I will tell you. Okay, just imagine, okay, integer, this is 32 bit, and the value 20 will fall under 2 power 1 to 2 power 32 combinations. Okay, so it will take it. But if you have x, okay, is equal to some value which is greater than 2 power 32, okay, then what will happen here is, just like I told earlier, okay, it will cut off the extra bits and it will take only 32 bits and it will assign to the x. Otherwise what it will do is it will throw an error saying that the uh, length is not matching, okay, for the data type. Yeah, so unsized by default it will be decimal. Okay, and also based on the left side operand, I mean sorry, LHS side variable, it will check if the value fits into the size of the this data type, left hand side data type, it will just assign it. If the right side value is, okay, right side value is greater than left side value, I mean left side variable length, then it will just truncate it or it will throw an error. Okay, so this is sized and unsized numbers. And also there is one more thing, okay, negative numbers. So can anybody tell me what is a signed number? I mean what is signed number and what is the unsigned number? Okay, Srinivas, you can tell me what is the signed number or what is the unsigned number? Or you have, okay, not, I think you, did you raise the hand, Srinivas? Okay, so who and all is there? Praveen, Bhavana, are you able to tell me what is the signed number?
Yes, sir.
Okay, what,
Sign number contains both positive and negative
both
sign.
positive and negative numbers.
Yeah.
Okay.
Unsigned have only positive.
Then if you have a signed number, okay, so how will you know whether that number is a positive number or a negative number?
Uh, MSB bit.
Okay, what about MSB bit?
MSB one
So
when
yeah,
MSB is one, it should be considered as a negative
okay,
number.
okay.
Mm. And
Otherwise, it will be kind of positive numbers.
yeah.
Okay. So everybody, okay, nobody is answering the questions or nobody is going like excited enough to answer or interact. I will be going one by one. I will be asking everyone the questions. Okay. So yeah, that's like a good answer. Okay. Thank you, Bhavana. Yeah. So that is a signed number. Okay, can have both negative numbers and positive numbers. Okay, the positive or negative will be based on the MSB bit. Okay, here in the coding, if at all you encounter any negative number and if you want to just assign x is equal to something like -10. Okay, so how it should be means x is equal to minus something like 6d 10, something like this if it is decimal. Okay, or if you are using, I mean these things, 6 tick d, if you do something like this, 6 tick d minus 10 after d, this is not a proper way, this is illegal. Okay, this is the right way. You have to put this minus before and then size, then format, then the value, something like this you have to use. Okay, and what will happen if you use these kind of things? Okay, these you people have to find out. Okay, I will give some task later the today's session. Okay, but you have to just find out. Okay, yeah, so anybody has any doubts till now? So I am going forward. Okay, yeah, so strings. Okay, so strings are nothing but value which is enclosed in two double quotes. Okay, something like hello world. So this is called string. How we will use strings, what and all, we will not do much work on the strings. Okay, but this is called string. Okay, this will be enclosed in between two double quotes, and for interview, each byte, if you want to save this string, sorry, each character will take 1 byte to store. That is the only thing you people have to remember. Okay, for right now. Then after that I will go to identifiers. Okay, so what is identifier? Okay, so if I go and check here, okay, okay, there is Mohan. Okay, so Mohan is the name. Okay, so if nobody has a name, we cannot identify them. Okay, so for identification only everybody will be given names. So these identifiers are also called, it's kind of naming only. So if I see Mohan, if I just call Mohan, he will, I mean, he will turn or and he will see. Okay, so if I call Mohan, okay, if somebody else is there, they will not turn back because they are not Mohan. Okay, so identifiers are just like names in the coding language. Okay, so when you have multiple variables, each variable have its own identifier, and also there are some rules how you will write an identifier or how you will write a variable name. Okay, so we'll go through that now. So let's say, okay, let's say you have an integer you want to declare, that integer name, let's say var1. Okay, so this is identifier. One more integer you have, okay, that is var2. Okay, there is lot of code. Identifier one, I mean identifier for this one, this integer, identifier for this integer. Okay, so when you create something like this, there will be some space created with 32-bit data. When you execute this line, there will be one more line executed with 32-bit data. Okay, so now if you want to store something in this one, this 32-bit data, it has the identifier, that is var1. When you want to store something into this 32-bit data, okay, you can access it using identifier called var2. And also when you want to read or write or whatever you want to do with some piece of variable, you can call it or you can use it, its identifier, something like x is equal to var1 plus var2. That means it will, the instruction once it executed, it will go to var1, it will fetch the value. Okay, after that it will fetch the var2 value. Okay, and then it will add it and then it will assign it to x. Okay, so this is called identifier. So when you create, a data type, you can have identifiers, and each identifier or each variable will have its own memory. And if you want to write something or read something from that memory, you can use this name so that it will specifically go to, if you use var1, that will specifically only go to this one. Okay, and if you use var2, that will go to specifically this one. Okay, so if you use var2, it will not go to here, it will not go. If you use var1, it will not go here. Okay, yeah. So here, what are the rules for declaring these identifiers? Okay, so first rule, I mean the rules are, when you are giving that, you can use anything from a to z. Okay, lowercase, you can use anything uppercase, a to z. Okay, after that you can use numbers also in between, numbers. After that you can have only two special symbols. Okay, those two special symbols are underscore comma dollar. These two things you can use to, I mean, like it is like a naming. It's like a naming. Okay, if you want to name some baby or somebody else, okay, what are the conditions which you have to use? So these are the conditions which you have to follow to name it. Okay, and with these also there are some more rules. Okay, what are those rules? First one, okay, the first letter rule. Okay, what is first letter rule means? In the first letter rule, okay, um, it should always, I mean, it should never start with either number or dollar. Okay, this is the first letter. First letter of the identifier or variable name, it should never start with a number or dollar. So if you are doing something like this, integer xyz, proper one, integer xyz1, proper one, xyz dollar, proper one, or x dollar yz, proper one. Okay, or x underscore yz, proper one, okay, or xyz underscore, proper one, xyz underscore 123, proper one. So we can have anything, okay, but we never used a number or we never used a dollar as a first letter. But if we use something like this, dollar $xyz integer, system will throw an error. This is wrong. Okay, this is not following my rules, so this is wrong. And also one more issue is 123 xyz. If you are trying to give something like this is wrong and this is wrong. So these are the, this is the first letter rule. You should never use dollar or you should never use a number, but you can use something like this, underscore. Underscore does not have any, like, it will accept it, underscore, and you can write something like this, x underscore x underscore yz also you can write. So what is your question?
Like what about hash and like special?
No, only two symbols, underscore and dollar. Those are the only two special characters which we can use in naming variables.
Yes.
Okay? Yeah. So I have asked you people to read keywords. Does anybody has read or did some background work on keywords? Anybody? Okay. I think you people are not interested much in doing tasks and everything. Okay, we'll talk about this later. Yeah. So keywords are, every language has its own keywords. Okay, so Verilog has its own keywords. Okay, these keywords will indicate some special functionality or something. It will indicate something like module is there. This is a keyword. I mean, these are the reserved ones. Okay, what is your question?
Like I studied, I know about keywords. Like those are three different words.
Okay,
Like, uh, they have the special meanings. Like we use modules like input, output, by range. These are the three different words, and they have their own special meanings. We can't use keywords as variables.
yeah, exactly. Yeah, good answer. So every keyword in a language, not only Verilog, you can take C, Java, Python, whatever it is. Okay, every language have its own keywords. That keyword will indicate some specific function or specific thing that we cannot use it in the naming also. Like you have some code, you are trying to do something like this integer, then you cannot just name it as module. Okay, so uh, these keywords will have its own special function and it cannot be used as a name. Okay, so there are a few questions, I will just give it after the maybe class. Okay, yeah, so this is going to be extended for maybe 30 more minutes. Anybody has any problem right now? If you
No,
have
sir.
any,
No
yeah,
problem.
anybody, if anybody has a problem, just raise. Maybe I'll take it in the next class. If everybody is okay with, I'll just extend it
No,
for
sir.
half an hour. Okay? Yeah. So just remember these keywords are special words which are reserved by the which are reserved, okay, for some special purpose. Okay, so Verilog standardized in something around 1980 and 1995, something like that. I've told in first session. So from 1995 till 2001, there are few revisions. Revisions means they might have added some special keywords and all in the later, I mean, in 1995 they might have, let's say, some 100 keywords, they might have extended to some 150, something like that. Okay, so keywords can be added or can be added in the revisions, and I see there are few revisions from 1995 to 2001. Okay, yeah, so I will not talk deep into the keywords because keywords are the things which we'll focus in the next sessions. Just remember that every keyword has its own function or its own purpose. Not function, you can just think it as a purpose. Every keyword has its own purpose. Okay. Now we'll move to the next topic, that is called data type. Okay. So yeah, now I'll be having some questions and everything. So can anybody tell me what is the difference between a software programming language and a hardware description language, HDL? Can anybody tell me quickly?
Sorry, I didn't get you.
Software programming language and hardware description language, what is the difference? Okay, I have already told this in the starting session. If anybody remembers, if nobody remembers, I'll just tell you. Okay, yeah, software programming languages, okay, they will try to take the information, manipulate the information and get the expected output. They will write the code to manipulate the data whichever we have, okay, but they will not, by using that software programming language, most we cannot describe a hardware circuit. Okay, for describing a hardware circuit or coding a hardware circuit, we have come into this Verilog, which is a hardware description language. The name itself will tell you hardware description language is something which will describe a circuit. Okay, so Verilog is a HDL, hardware description language. People will might ask you, for the freshers, what is a HDL, what does it mean? Okay, that means if you have a circuit something like this and you have an AND gate, and then if you have a OR gate, okay, something like this, A B C, then Y, okay, using Java, okay, using C, those things and all, you cannot do this thing. You cannot tell the machine we have AND gate, we have one wire here, one more wire here, one more wire here. You cannot tell that. But using Verilog, okay, the whole purpose of Verilog is to do this. Okay, not only Verilog, before that VHDL. Okay, so the purpose of these HDLs are to represent these circuits in coding. Okay, so A B C and Y, if you take something like this, we can not do it in software programming languages. For that we have come to Verilog or VHDL, or maybe next level is system Verilog, this and all. Okay, so these are called hardware description languages. Now, okay, I'll, okay, so a bit have, if you have a single bit, how many combinations do you have? As Shirisha already told, it can have two combinations, that is 0 and 1. Okay, so here, uh, but if you go deeper, okay, everything will be designed using transistors. Okay, the flip flop, okay, the gates, everything. If you go internally deep down, lower levels of abstractions, it will be mostly transistors, and before that if you go some p p type semiconductor, n type semiconductor, everything. Okay, but lower level of abstraction, it will be, sorry, mostly transistors. Okay, and transistors, how it will work, it will work on currents and voltages. Okay, so if you have a single bit, with the name called x, x can either have 0 or 1. Okay, so 1 can be represented something around 0 to 8 volts to 3 volts, and 0 can be represented as 0 volts or ground. This can be called as VDD also. Okay, so here, okay, if you take something like this 0, 0.8 volts, okay, there are there is one more state, okay, something which lies over here, that cannot be 0, that cannot be 1, it can be neither. Okay, so there is an ambiguity. Okay, so if you have something like this, x is equal to 1, x is equal to 0, okay, when these two things are getting executed at the same time, then what will happen is x value will go into unknown state. Okay, sorry, this, let's take this variable something else, y. Okay, so this y will go into unknown state. Okay, this unknown state will be represented using x. Okay, something like 0, 1, some this region x. Okay, here if you see this diagram, okay, if this is given to some other AND gate, something like this, if this output of this AND gate is not connected to anything, it is not connected to anything, okay, it is not even output of the block, or it is not connected to anything, so what will happen, it will be hanging. Okay, it will not do anything, it will be hanging. Okay, this state is called high impedance state, where a wire is hanging. Okay, got it? So if we have a 1 bit, it can have 4 values, 0, sorry, 1, 0, it can be unknown, or it can be high impedance. Okay, anybody got any questions?
No.
Shall I move forward, or anybody has questions?
No question, sir.
Okay, everybody, I'm moving forward. Okay, so in Verilog, this is called, okay, uh, this is called a variable which can hold, this is called a 4 data type variable. Okay, so a variable which can hold any one of these is called 4 data type variable. In Verilog, we have 4 data type variables. We don't have 2 data type variables, but if you go to system Verilog, there we can have 2 data type variables. That means that value can be either 1 or 0. It can never be x, or it can never be z. Okay, that is in system Verilog. Let's forget it for now, but in Verilog we have 4 data type variables. Okay, and yeah, so that can take any of these 1, 0, x, z. Just remember these things, these basics are very important to crack the interview. Okay, so don't get confused. Okay, 1 means it will be here, 0 means it will be here only, x means it will be somewhere around here, z means it's nothing, like it's hanging up. Then, so what kind of variables we have? So, sir, what kind of data types we have in Verilog? One is nets, range, integer, okay, real time, real time. Okay, these are all the variables which we can have in the system Verilog. Sorry, in the Verilog. Okay. Yeah, actually I wanted to continue, but this will take more than half an hour to teach you the basics of it. Somebody said wire. Okay. Wire is one kind of net. Okay. Yeah. So next session, that which will happen tomorrow only, I will be asking questions. People who don't give answers or people who don't want to interact, I will just kick them out of the meeting, because if you don't do what I ask, okay, that means you people are not interested. Okay. So for tomorrow, what you have to do is you need to go through, I mean, read about these things. What are different data types in Verilog? What is net? What is range? What is integer? Real time? Real time. You people should read. Okay? Even if you don't understand, just read it. But if I ask you some question about these things, you should be able to give an answer whether it is right or wrong. It does not matter. Understood, everybody?
Clear.
Yeah. So what is the question?
Actually, you told about signed and unsigned, na?
Yeah.
So, for example, think there is a 4 bit like 1111.
Okay.
So if they don't mention like 111 is a 4 bit, so we can take it as signed or unsigned. For committed signed, it's
Okay,
like
so regarding this question, okay,
in.
first what you have to do is you have to read what is the signed number, what is the unsigned number, okay, that first you read. After that, if you have any questions, I will take it up. This
Okay.
is more, I will be concentrating on Verilog, but you people need digital concepts and everything, okay. So yeah, you people will read about these things. And next, data types. Sorry, no, not this one. The people will read about all these things. Okay, data types. After that, next you will read about signed, unsigned numbers. Okay, ones complement, twos complement, techniques. Okay, why we need ones complement, why we need twos complement. Okay, these all questions I'll be asking. So for next session, which is tomorrow's task, you people need to read about these data types, signed and unsigned numbers, so ones complement, twos complement, and ones complement, twos complement representation of unsigned numbers or signed numbers, and conversion if possible. If I give just a decimal number, you have to convert it into ones complement form, you have to convert it into twos complement form. Okay, somebody please take a picture over here and put it in the group. This will be the task for tomorrow. Okay, so today's topics and everything is done. So in today's topics, does anybody has any doubts? If nobody has doubts, I will finish the call right now. But whenever it is 8 o'clock, you people should be there in the meeting. You people should be ready to join the meeting. I don't want people to be joined at 8:02 or 8:03 or 8:05 or 8:10. Okay, I'm a working professional. I'm taking my time to teach you people. If you people don't join on time, okay, I don't have any intention of teaching you people or accepting your request. Okay, so tomorrow onwards, if anybody joins late, I will just not admit them. If you want, I'll start the meeting 5 minutes early. If it is 8 to 9, I will start at 7:55 only. You just be there and attend the meeting. Is everybody in the WhatsApp group here, or anybody is not there in the WhatsApp group?
Actually, my friend is not in the WhatsApp group.
Okay, you people take uh, Praveen will send the link. Okay, you take that link, you try to join. I will accept you people, but be on time. Okay, everybody join on time. And today I did not say anything. Okay, even if you people did not read anything which I asked you people to read about multiple things. Okay, those things are like data types. What is it? Keywords, identifiers, data types, and model structure. Half adder, full adder, multiplexer, demultiplexer. Okay, I don't think you people have read these things because nobody said I have read or I have gone through these things. Okay, what I'm trying to do is I'm trying to make you people ready for the interview and everything. You people should be serious. Okay. Okay, that's enough for today. So we'll be meeting tomorrow at the same time. Okay. Thank you guys.
Thank you.
Thank you so much.
Okay.
Thank you. Thank you.
You
Thank
can
you.
one more thing. You can use that Verilog group. Okay, to ask your questions or clarify your questions. Okay. Yeah, everybody except Mohan can leave.